opportunity to. So once again, good afternoon, and for some people joining us from overseas, good evening, and a very warm welcome to our session 2 in the Advancing Caribbean Teachers Act in Math webinar series. And we are always delighted when Caribbean people can come together in different ways to achieve positive things. And we are absolutely excited to have such a diverse range of persons here today. I know from the chat, I can see we have principals, we have teachers, we have numeracy coaches, education officers, parents, just a wide cross-section of people, curriculum officers, etc. And as I've said before, even from our first session, that this reflects that spirit of collaboration that lies at the heart of this Act in Math initiative. And we have said this before, but it is worth repeating, that it is more than just professional development. It's about empowering teachers, empowering math educators, building confidence, and most importantly, transforming our classrooms to be places where children love math, they have fun engaging in math, and they learn math, not just for an exam, not just for an assessment, but for the bigger importances of math in our world. For example, developing critical thinking skills and reasoning and using math in everyday occurrences. So we are hoping that this set of series over this year, because it's going to be 7 sessions across this academic year, that we will see direct improving in our student learning outcomes. And just as a reminder, we are going to go quite quickly into the presentation. The webinars are held monthly, every 3rd or 4th Tuesday, and each session will spotlight, different aspects of our math education practice and what we can improve. So as a teaser for next month's session, which will be on November 18, we will focus on breaking the fear barrier, transforming math anxiety into confidence. And this is an area we find many of our students, they're afraid of math, they have had negative experiences in math, and we really want to tackle this topic head on. We want to, as always, acknowledge the presence of Dr. Chantal Moore, the advisor for the Commonwealth of Learning, VOSC, and of course, our very hardworking country coordinators from cohort 1 and 2, Mrs. Nicole Franklin from St. Vincent and the Grenadines, our very own presenter this afternoon, Mrs. Carol Bodie from St. Kitts and Nevis, and Miss Jonella Gifford from St. Lucia. And as it relates to our country coordinators for cohort 2, we want to say a special welcome to Mrs. Frances Thomas from Grenada, Kim Best from Barbados, and Meloticia Mills from Dominica. So just a few housekeeping matters before we go into the presentation. I'm going to ask, can we keep our microphones muted unless speaking, and feel very free to share comments, questions in the chat. We will definitely have a Q&A session towards the end of the presentation. So without further ado, it's been a long day. We do not want to waste time. It is really my pleasure to just introduce Mrs. Nicole Franklin to us. So some of you may not be, very aware of who she is, but we want to make her feel very welcome and to introduce her to our collective group of Caribbean professionals this evening. So Mrs. Franklin is a dedicated educator with more than 34 years of distinguished service in education. She spent 25 years as a primary school teacher, teaching across all grade levels, and she also tutored at the secondary school level in mathematics. For the past 9 years, however, she has served as education officer for mathematics in the Ministry of Education and National Reconciliation in St. Vincent and the Grenadines. So in that particular role, she continues to shape curriculum development, instructional improvement, and teacher professional development, alongside the very hardworking team from St. Vincent and the Grenadines. And we want to give a shout out to so many of you who have shown up today. As the national coordinator for the Commonwealth of Learning's Advancing Caribbean Teachers in Mathematics project, Mrs. Franklin provided strong leadership and organizational support. She was absolutely instrumental in mobilizing teachers, encouraging participation, and supporting the monitoring of classroom practice during and after implementation to promote sustainability. Her work has strengthened. One second, please. Sorry. Her work has strengthened teachers' content knowledge and pedagogical skills, while at the same time advancing inclusive and culturally responsive approaches to mathematics instruction. She remains deeply committed to helping every child experience success and confidence in learning mathematics. And just in case you think that Mrs. Franklin is one-dimensional, pun intended, for the math people in our midst, I'm sure you got it. She's also a former national volleyball player, coach of the national women's team, and a certified FTVB volleyball coach. And before I hand over to Mrs. Franklin, I am Dr. George, and I am the co-lead for the Acting Math project and the webinar series. And it is my absolute pleasure to be your moderator this afternoon. And our job, and my job as a senior lecturer in math education at the University of the West Indies Mona campus is to continue to work as hard as we can, to make math more accessible to more children, to more teachers, to more people. And that's our goal. So without further ado, I'm going to hand over to Mrs. Franklin. And yeah, let's just make her feel welcome through the emojis, through the chat. Over to you, Mrs. Franklin.
Thank you very much, Dr. George. You're still sharing, so.
Yes.
Pleasant good afternoon, colleagues, and thank you very much, Dr. George, for the warm welcome. And thank you also, colleagues, for welcoming me. I trust that you are able to see my screen at this time. I hope everyone is seeing. Just let me know.
Yes, we are.
All right, thank you very much. I almost thought I would not have been able to make it this afternoon. My voice is not so good. I seem to be coming down with a cold, but I am really grateful that I was able to make it on today and be able to share with you my colleagues across the region. Just for okay, so when the opportunity, came to really delve into this, I thought, you know what, this might be something really good. And even though I've never seen the BAM model as a a student or even as a teacher, I am grateful for the opportunity to really look at this and see how, it can help to transform how our students see math, and even as teachers, how you too can, act in the whole transformation of our students. Now, to begin, you're gonna be shared with a poll at this time, just to break the ice. I want you to go ahead at this point and, just answer those questions that you see there. The question that you see there, you could choose as many options as you wish. Just go right ahead. Um, I do not know what place you might be or where you are, but think of how you would answer those questions. All right, I'm seeing that many of you are thinking that you need to use more concrete and pictorial materials in the classroom. That is good. Allowing time for students to collaborate and think. All right, very good. All right. Placing yourselves in the student's shoes. That comes in at third place. I'm seeing, let me check again. Let me make sure. All right. Now, based on what I'm seeing here, everybody thinks that, in your philosophy is that concrete and pictorial mathematics materials are important in the mathematics classroom. And also collaboration and even placing yourself in the shoes of your students. What is interesting is that I didn't see anybody say that they are relying heavily on traditional methods or telling the students what to do. And that is good. If we are thinking about transforming our students, I think that, those are very good qualities, or those are good philosophies to embrace as we go forward. Okay? All right. So, Dr. George, you could probably let's see. So, yes, we had you really looking at the students and thinking of the students and what they would need. And I'm really happy that you're thinking that the students really need to have those concrete and pictorial materials a bit longer in the classroom. They need those. Thank you very much, colleagues, for sharing. Dr. George, you could probably take it down at this time. Let's see. All right, so let us continue. All right. Now, in mathematics, we normally talk about the processes, math processes, and these are very important when we are thinking of math and when we are looking at what is involved in the whole process of doing math. One of these processes is representing, and this is where we have different ways to show um, ideas in math. So we may use graphs, we may use diagrams, we may use numbers, different symbols, and so on. So math is being represented in different ways. Also, it is important that we take into consideration how students make links with concepts that they are learning, links to concept across the math program or the math curriculum, and also how they make those links to the real world. Okay, these are critical as we are trying to embrace this topic that we are going to go into today. Also, communication. How do we get our students to express what they are learning? How does the language of math come up in the classroom? How do we allow the students to draw meaning when they learn things in other subject areas? It may have a different meaning. How do we get them to communicate that meaning within the math class? So these are things that we have to consider whenever we are doing math, the different processes that would come up. So another of those processes are, we have two on our screen now. We are talking about reasoning and also problem solving. In reasoning, are we allowing our students to say, this really makes sense as I go through this pattern, or I can justify my answer based on how this thing works. And if I do it repeatedly over and over again, it will still hold. So it operates in a way that is logical. It makes sense. It could stand the test of time. I could justify it. Okay? And this is what we want with our students, to be able to justify their answers. Even for problem solving now, we want them to be able to be challenged. We want intellectual challenges for our students. We cannot have them skimming on the surface all the time. We want to dig a little deeper and provide rich tasks that will challenge them, and improve or enhance their mathematical understanding. These are the processes involved in math, and they are important so that as we do different strategies, these different processes come out, and we have to let the students see how they are coming out and how they are interwoven into what they do on a daily basis. Okay? Now, you may look at this, and if you are probably a grade 6 teacher or maybe somebody in Form 1, you might be saying, why do I need to know this at this point? But you see, these are very critical and very important to our students' understanding. They might seem like foundational principles, concepts that our students need to understand, but they have far-reaching effects later on as to what they learn. So, for example, if a student in grade 2 or grade 1 or kindergarten is learning that 7 can be partitioned using 5 and 2, so we have the whole as 7 and we have the parts as 5 and 2. Why at grades 3 and 4, why can't they transfer that knowledge to be able to say that 70 is 50 and 20, or 70 or 700 is 500 and 200? And it might seem simple, but these are the building blocks to what we are talking about in terms of when we get into the whole part, the whole and part method, when we are doing the bar model. And even if we look at the fractional part, to get to our whole, we are seeing there that our whole can be also shown as a number bond. Our whole can be 3/5 and 2/5, and we can do that for any fractional part that we want to do. So our students are seeing the pictorial representation on this side there, 3/5. what 3/5 look like, what 2/5 look like, and they're seeing the number band that represents this information. So all these are important to what we are going to do in our bar model. Okay. Now, as we are going to get into the bar model now, because of the way I'm sharing, Dr. George would be able to help me. I want you to type in the chat your definition of a bar model. Type your definition of a bar model. Okay, Dr. George, could you read any of those for me, please? Any?
No problem. We
Thank you
have
much.
many coming in.
You just do a few.
No
Yes.
From Amber Cole, we have a diagram of a math process. Then from Samantha James, we have using bars to show part-whole relationships. And then Michelle WD says it's a pictorial method of solving. Claudicia Robertson Lewis says it's a visual representation used in math to show the relationship between numbers in a problem. Amber Cole continues to say it's a demonstration of a math equation. Al Martin Duncan says bar model is a simple visual tool, uses bars or rectangles to represent number or quantities. Frina Balcombe, bars representing information, numbers. Daniel Williams, the process of using bars or blocks to represent different portions in an equation. Other responses are visual representation using shapes, a rectangle that can be divided into linear strips to model quantities in a ratio.
All right.
And I'm just going to read a couple more because they're coming fast. It's a bar model is using rectangular bars to show the relationship between a whole and other fractions, a pictorial representation of mathematical concepts, and it goes on and on. Thank you so much for your participation.
Yes, thank you very much, colleagues. So I'm glad that many of you have, some understanding of what the bar model is, or maybe some of you would have actually seen the workings of the bar model in the past. So some of you, it might have been that you saw it, but you really want to, get a better grasp of it and so on. Maybe the first time was just seeing it and now you really want to get into it. So today we are hoping that we will be able to strengthen your understanding of the bar model, even as we work you a bit today to try to, as you try to solve some of the problems that will be posed. So the Singapore bar model method is what we are going to talk about, and it's mostly recognized throughout the world. Okay, this one is widely recognized, and what I like is that it's hinged so much on the CPA model, which we have through the Advancing Caribbean Teacher project in mathematics project. We have been really putting at the forefront the CPA model, the concrete, pictorial, and abstract model, and this method, the bar model, strengthens that so that students who have questions about abstract concept could have a physical and visual or visual aid to help them to be able to approach these questions. Okay, so they are not left in the dark to be able to help themselves. Okay, so it's a visual tool in mathematics. Many of you would have mentioned that it uses bars, rectangular bars, to represent known and unknown quantities. Okay, so you're going to see that it has bars, and quantities could be known or unknown, and then it helps to really, the students are able to visualize mathematical structures and relationship between different values. So they are able to make connections with what they are seeing and understand the relationship. When things are just in black and white, they don't understand it. But as they work with the bars, they are able to see the relationship between and among the different structures they are working with. Okay? What I like also about this is that it promotes conceptual understanding. Now, many of us learned in the traditional way, we're just using algorithms and so on, and it was do it this way, and that is how we did it. The bar model promotes deeper understanding. Deeper principles come to the forefront. So students are now able to understand why certain things they're doing certain things, or why certain things are the way they are in math, because they are now delving a little deeper and they are gaining conceptual understanding. So when we were told place a zero if you're multiplying by a two-digit number, we just thought, well, the teacher said put the zero there, we put it there. We didn't have the conceptual understanding at the time to know what is it really that is, why are we doing that? We didn't get the why. So with the bar model, it's digging a little deeper to promote conceptual understanding. Also, many of our students sometimes they jump from students working with concrete stuff straight into abstract concepts, and we are one, and sometimes this is where the math breaks down with a lot of our students. They jump from the concrete straight into the abstract, but the bar model creates a bridge. Okay, it bridged that gap so that clarity could be made to the students. They could understand a lot of things that didn't seem clear to them. Okay, they understand the part whole relationship, the same little number bands that seem so simple. Yes, they become important, they take shape, they have meaning, and the students are able to know what are the operations that I must, engage. And what we are really working towards is mathematical mastery. This is what we want in our students. We want our students to reach to a point where things are second nature to them because they have the conceptual understanding and they can bridge that gap between the concrete and the abstract. And this would lead to mathematical mastery. Sometimes our students are able to solve certain things, and we might say they have attained mastery, but they still don't have the conceptual understanding. So with the bar model, it works in favor for the students in terms of getting everything from the concrete to the pictorial to the abstract. Okay? So if we are to look at the different types of bar models, type 1 deals with those looking at the part whole. So just like what I showed you in the number band, you know the total, you break it into parts, or if you know the parts, you try to find the whole. You may have the whole and a part, and you have to get the other part, and so on. So the bar model, the first type, shows the part whole. Okay? And these work best when we do things like addition and subtraction. Then you have the second type, which is the comparison model. And these use, they compare amongst where one is more than one or greater than one, or you might find that you have a combination of, of both models in the comparison model. But we'll get into some of these as we go along, and you would see how they are used. So, what benefits are there to be derived from using the bar model? We spoke about this conceptual understanding. No more do we want our students to just have rote memorization, to just regurgitate things as they are, but we want them to be able to, for themselves, understand the why, those underlying principles, those things that are there, that really speaks to the meaning of what is happening, the comprehension, pulling that information out. We want the students to build that. We want them to be able to problem solve, to be able to use strategies, different strategies that would help them to arrive at a solution. And this, problem solving involves so many different type of strategies. Again, the CPA approach, the concrete pictorial approach, abstract approach, the bar model leans heavily on this also in terms of helping our students move gradually along and understand how the concrete, the pictorial, and the abstract work, they're seeing things at the different levels, and they are able to gain meaning. They are able to make the connections better. The bar model is very flexible. It could work well in different areas across mathematics. It could also, in terms of the way it works, you have the different methods the types that we look at a while ago. So it's flexible in all those ways to help our students. One of the things that the bar model is very good at is helping students to visualize the problem. To just see numbers or words, it might not resonate with a lot of students. They do not get the understanding. But when you visualize, when they're able to see, you represent it with a drawing, a diagram, they are now able to visualize the problem and make sense of it. So the different parts of the bar would have representation to the students. Also, the bar model will tell the students what operations or what are the necessary calculations that you would need to do as a result of pulling or putting the bar together, setting up the bar. The students are able to see the calculations, the necessary calculation. When you have multi-step problems, sometimes it's difficult to just write that down in numbers or even in words, but the students are able to set this up now through a model, the bar model, and they are able to put their multi-step problem together, and it makes sense to them. So again, this multi-step problem is represented, just as we say, they're able to visualize the problem. So we have these working in harmony, and as we said before, because it's so flexible, year after year, students will be able to see that the bar model could work along many different areas in mathematics. Okay, many different topics you could actually use the bar model. So how is the model really used? So we allow students to read and understand the problem. So they go through it and they try to, make sense of what it is saying. What is it? What is the meaning that I'm drawing from this information? What is the information telling me at this point? When I read it, what is it saying? Okay? And then you go ahead to draw the bar, draw a bar, okay? You represent the information that you have read with a bar. So now you're putting it together so that you could visualize it, so that you could look at it and say, this is what I have read and understood a while ago, okay? And then you partition the bar based on what you have read and understood about the problem, what you have drawn. You now try to represent that information by partitioning the bar. So you're cutting your bar up in parts, okay? And then you represent, it says represent unknowns here, but you represent the knowns and the unknowns. Based on the information that you have read, you give those details that you know or you see coming out there, and then you also try to represent what is unknown. Okay? So the known and the unknowns you're going to represent. And then you get to determine the operation that should take place. What is it that I'm going to do? Am I going to add? Am I going to subtract, multiply? What is it that is required of me to do at this point? So the students need to use this as a model. How do I go about approaching or using this model? Okay, so read and understand, draw a bar model, draw a bar, partition, represent the known and unknown, and then determine the operation. That is important for you as we go along. All right, so what is important now is that we understand the workings of the bar model. We are going to see how it is actually used, okay? And you would see that we would have the different types coming out. So if we are to do addition and subtraction, I have a question here. There are 20 cupcakes in a tray to be shared between Ray and Sid. Ray got 9 cupcakes. How many cupcakes did Sid get? So we want to represent this information using the bar model. So if we look at the problem here, we can easily look for certain information. Louis, as we go along, I would ask some questions. Maybe persons could put it in the chat. So we talk about addition and subtraction, working with the first type of the bar model. So it talks about parts and the whole. So if we look at this question, quickly type in the chat, what information do we know that you could get from this information here? What do we know? Quickly, 10 seconds. Any responses, Lois? You could probably let us know.
Sure, they are coming in. They are coming in. All right. So we have several responses, and we have the whole is 20 and one part. Then there are 20 cupcakes. Then we have total of 20 whole and one part. That's a deviation from the other responses.
Right.
2 to share with. That's another difference in response. 2 to share with. We have 20 is the whole. We have whole is 20 and part is 9, shared in 3 parts. So we have some diversity coming through. Total 20, one part 9. Total is 20. We have Ray got 9 parts. Number of cupcakes to be shared, 20. 20 is the whole. 9/20 belongs to Ray. So further diversity. Whole equal 20, one part equal 9, 2 characters in the story. All right.
Good.
So that's what we have.
Lovely. So I think I heard you say somebody said we have 3 parts. I'm not sure if but I'm not sure what they mean by that 3 part. But anyhow, most persons would have identified that 20 cupcakes is the whole, okay? And we have a whole and we have to share with Ray and Sid. We had that information, okay? We heard the teacher say that. So we have our first bar there with our whole of 20. The other piece of information that some persons mentioned, yes, we know that Ray got 9. Okay? So how many cupcakes did Sid get? So with this, we want our students to see the whole. We got a whole and we only got one part of the whole. Now they have to determine what is it that I need to do so that I could get the other part. Okay? And so the other part is unknown. We do not know the other part. And we know, I mean, we are teachers here, so we know what to do to solve. It would be 20 minus 9 would give us the other part, or we would have some students who would simply count on and get to 20 so that they could get the answer. All right? So that is one way of doing the. So we have another situation here. And when you look at this, we have 2 individuals here. We have Jen and we have Andy. Let's go. What do you think this is telling us? You see this bar. What is it telling us? You have a question mark in there. What do you think it is telling us? I think some persons are drawing on top. They are using maybe the whiteboard or something. So
Okay, can we just encourage attendees not to annotate because it's not a whiteboard at the moment. It's just the presentation board. Thank you so much.
Yes. All right, so did anybody share anything in the chat? Once you see the question mark in that, what might it be saying?
Okay, so we have some responses. It says you need to find the whole. Then we have a whole has to be shared between 2 persons, but the amount is unknown. We have it is asking us for the whole.
All right.
The responses, just a couple more. One whole has to be shared between Jen and Andy, and somebody's asking or stating what is the whole, how many does each get? So we have a variety of responses.
All right, so we have 104 on the screen here. Can we still find the whole? No, right? Because we only have part. So now we have the other part and we are able to find the whole. So there was actually a question for that, okay? And our whole is unknown in this situation, all right? So if we are to take it from the top, the question is posed. We want to know how many they had all together. We know how many Jen has, how many Andy has. We are able to get the whole because the whole is unknown at this time. So we can get it by adding the two of them. All right, let's move along. So Mary had 120 more beads than Josh, who had 68 beads. So I'm going to ask you, colleagues, to solve this one, okay? Quickly. Mary had 120 more beads than Josh, who had 68 beads to make craft items of their choice. How many, something is blocking me here. All right. How many beads did Mary have? And how many do they have all together? So I'm going to let you solve that quickly, colleagues. Think of it, how you would arrange your bars and what would happen. Well, you wouldn't draw your bars in the chat, but at least what would you get for your answers? Put them in quickly and we'll see how we arrange the bars.
So in the chat, we have Mary 188, together 256, and that's quite consistent across. Yes.
All right. Lovely. So we have.
Somebody said, by the way, Mary 188, together 188 plus 120.
Okay. So we want our students to be able to represent this. And we know, so we are looking, we need to identify Josh, Mary, and then we need to get the total all together. So we know that Josh had 68. That is mentioned there, okay? So, and then it said Mary had 128 beads, 120, sorry, more beads than Josh, which means she had Josh's 68 plus 120 more to give her 188. So if we want to know what they have all together, it would be Josh's number of beads added to Mary's 188. Are we okay with this, colleagues?
Could you go back to the screen for me, please? With the bars. My question is, should the bars be proportionate to the amount? Sorry for that, Victoria. Should the bars be drawn, the length of the bars, should it be drawn to, in a visual way to represent the amount that they represent?
So are you asking if they should have looked a bit more, one more
So,
than the other, okay?
yeah, so for instance, the 120 I'm asking, should the 120, that bar, that darker blue bar, be at like almost 2 times the 68 bar?
Right. We understand that. But I guess we did this to that's a good point that you are making there, so that the students, I mean, in their minds, they could also see the relationship in terms of numbers and what they look like. So 120 would be, almost like twice or more, okay? Just a little less than what 60, less than 68 being doubled, okay? So it's a good point
Ms.
that you're raising there.
Franklin, the chat has come alive. Persons
Yes.
are in different perspectives. So I'm just going to read a few. Someone is saying that would require a scale, higher levels, it could. Another said the students would not know about drawing the scale. And
Yeah.
somebody else says, I agree with Mr. Holder. We should show the difference in size and colors. Yes, it is important to see not just the numbers, but what other kind of symbols. And then we have a question coming out. Does the size of the bar really matter?
Right.
And then finally, we have one of our principals weighing to say, so quite interesting discussion. Thank you everyone for weighing, and that means you are listening and participating. One of our principals is saying a child may draw 3 bars, 66, 68, 68, and 120. And final exchange, yes, the bar size and colors matter. Remember that students have diverse learning styles. Over to you.
All right, thank you. So it depends on which level you are working with the students. The size or as you're saying, even level of students look at certain things and to make certain generalizations or come to certain conclusion. When you say 68 beads and then somebody say 120 more, some children in their mind, certain things go off and they might say, how would that look, when you represent it and so on. So yes, it can work. And then again, depending on some of the students, you may not need to use, to scale it as such for some students. It's really getting to understand what this is saying and trying to pull the information. But yet, yes, it is important because as they go up, the whole idea of the the scale and the relationship with these bars become very important. And you would see that as we go along. Okay. Thank you very much for raising that concern and sharing your thoughts also, colleagues. So if we should go to one with multiplication now, this is a simple way to multiply. It's a simple question, and if you notice, we are trying to start with very simple items for the introducing the bar model, because we could introduce it to our students at different points at the primary level and also different points at the secondary level. So you could have some students simply representing it like this. So 3 boxes of plates and each box containing 5 plates. Some students may represent it like this in the bar. Okay? Others may simply do it like the on the right. Okay? So they are using the bar model and they are making their representation also. Okay. So let's go to some fractions. So we have Sandra with $125. She spends 2/5 of the money, saves 1/5. And the question is asking, how much money does she have remaining? And here we want to also make sure that the students are seeing that it's not asking about the fraction. These are things that we have to, really cement in our students and get them to see. The relationship with the fractions and the money and so on it's very important. They need to know these things, but they also need to read and understand the problem. And we need to get our students to be able to do that. And the bar model helps with that a lot too, because sometimes they really don't want to read because they feel I have to do something difficult and so on. But with the bar model, they are more tempted to, or more, they feel at ease to read because they are able to represent the information. So I'll do this one. We'll go through this one. So based on this, $125 is our whole. Okay? So let's represent that. That's our whole. And also, I'm putting them in pieces, but as your students get better, they would be able to work on one bar and represent the information. But for those who are seeing it for the first time, I'm taking it in steps so that you could understand it. All right. So we are working with fifths, obviously. So she spends 2/5. Look at what 2/5 being shaded there. And she saves 1/5. Okay. Our 1/5 is also highlighted there. Now, the rest of the money, how much money does she have remaining? So we have, if we are making fifths, we know that we would have 5 parts here. 2/5 went for spending, 1/5 for saving, and 2/5 remaining. But the question didn't ask us which fraction or what fraction remain. So we get our students to see that we have $125 and we want, because we are working with fifths here, we proportion our $125 in our fifths. And each fifth would be $25. So if we take our 125 and we share it up 5 times, those 5 parts, we'll have $25 in each part. So we know that she spent 25 and 25, 2/5, so that's $50. She saved $25, and she now has the 2/5 that remain in there, 25 and 25. That would give us $50. Okay, so I'm trying to expose those persons who may not have, used it before to work a problem like this. So you could see your students working through a problem like this when they don't just want to work with numbers only, or numbers is a problem. No, earlier on we talk about the math processes and the different things involved in math, and we have to make the connections with our fractions, the things that we are learning in different areas. We bring it to this problem here also. So the connections are very important. Look at how fraction is important to how we are doing or approaching this question. So the different things are the different processes. We have to bring them to the problem so that the students see. So they make the connections. Okay?
Excellent. We have a question, Mrs. Franklin, in
Yes.
the chat.
Yes.
Mrs. Prendergast Ellis asks, how about one bar divided into thirds, each third representing 5?
One bar into
Yes.
thirds.
How about, I'm Sharon, I'm hoping that we're talking about the same question. How about one bar divided into thirds? And if you want to just open your mic.
Yes, my friend, I would love to hear that. I'm thinking I understand where you're coming from. So let's hear. Go ahead.
I'm
And it
quite
was the
interested in hearing.
it was
I'm
the
Yes.
quite
previous
interested in hearing that
Yes.
approach to the problem. So I would really like if the person could explain.
Yes.
Ellis, if you have a mic and can unmute, please share.
Good afternoon. It was the previous question with the multiplication, the 3 5s. I don't remember the question right now.
This one?
Yes.
Yes. So
So
what?
1 bar divided in 3 parts, each representing a box, and then I would kind of put 5 in each third. So 5 plates in each box.
But that is what we have represented there. There are 3 boxes. So the blue represents one of those boxes, the red, one of those boxes, and the yellow represent one of those boxes.
Okay.
And then each of them,
Yes.
5 plates.
All right. I'm seeing it, but I was thinking instead of dividing it in 5, it would just be a single blue bar, for example, but I would have written the number 5 on it. But I guess it would be the same concept.
Now, I'm not sure your line of thinking, but we know that if we multiply 3 times 5, we will get the same thing as if we multiply 5 by 3. But the important thing is that we must show that there are 3 boxes. And it didn't say 5 boxes with 3 plates.
No,
So,
I'm saying three boxes, yes. So I would have just divided the entire bar in 3 parts. So for example, the blue would be a part, the entire red would be like one section, the entire yellow, not divided as you have it, but I would just write, for example, 5, 5, 5 in each of those 3 boxes. I don't know if I'm explaining it well enough.
well, using the principle of the bar model, and how it should be represented, I was hoping that we could all see that either of these ways it can be represented. All right? Thank you for sharing though. Okay? All right. So we move ahead. So I'm going to give you one to try or think about. Okay? So Mark made 300 tarts. He sold 3/4 of them and gave away 1/3 of the remainder. How many tarts did he have left? Interesting. So think, do we have, what information do we know? Do we know the whole? Do we know part? What is it that we know? We have fractions. What do we do with the information that we have? Maybe in the chat, you could tell us, what do we do with such a problem? Even though you cannot go all the way down to the end, just say what you would do to approach this question. I can't give you too long because of time, but
I could do the first part, but I get confused with the other. I could divide the whole bar into 4 equal parts, but I get confused after that.
Sorry.
Well, if I may try,
Yes.
so I would divide the entire bar by 4 into 4 parts. 3 of them would be shaded in one color to indicate that 3 out of 4 sold. And then the remaining 1 bar that is left, I would divide that into 3 parts and shade one part, and then the two that is unshaded would be the amount that is left.
All right. Thank you very much. I'm not sure of your name. Tell me your name quickly.
Oh, but then bent.
All right. So, Mr. Bent, is this what you're saying here? So we have 300 tarts. He's saying he knows that it's the whole. He'll cut the whole into 4 equal parts. So he would share. If we share those 300 tarts among the 4 parts, each part will get 75. Our students need to know how to divide, okay? So even though they're doing by a model, they still need to know how to divide. So each part gets, look at it, and look at
So
what
yeah,
Mr. Bench
that's
said.
what I'm saying.
Right. He said, share those first 3 parts, the 3/4 that he sold. So that's 75 by 3 he sold there. But the question said he gave away 1/3 of the remainder. So if he sold 75, he still had 75 remaining there in the pink. All right? But he gave away 1/3 of that. So we have to take our 75 now and split it into thirds. And if you have 75, and we could easily do that with our students and say, if you have 75 cents, how much would each part have? They would quickly tell you 25 in there. So if 1/3 of that remainder was given away, what is left? Those are the 2 parts. When we add 25 and 25, we're going to get 50. Hope we are okay with that one so far. Okay?
We have a question in the chat asking if or stating equivalent fractions is a prerequisite for this question. How would you respond?
Somebody is asking if equivalent fraction is important here. In this particular question, where I'm not seeing per se equivalent fraction, as in, but I'm seeing equal portion. Okay, you're cutting. So for example, the 75 in pink is really a quarter. But we have taken that quarter and we have made thirds with it. It's no longer a quarter. It is a quarter per se. It is a quarter. So it's equal. But in terms of the fraction, we are no longer working with quarters. So you have to be careful how you say, is it equal? The amount of money is equal, but the fraction is not equal there. Am I correct? Are you not correct, but are you seeing what I'm saying there? So $75 is there. $75 is at the bottom. But each of those represent a third now at the bottom, while up at the top they represent a quarter.
Sister Franklin,
Yes.
my question to the person who asking about where is the equivalent coming from? Why the question
Right.
about equivalent fraction?
Right. It's right.
So no, if the person could share with me why ask about equivalent fractions here.
So Mrs. Joseph is saying she's seen the point now that no, in this case it is not. So this is such amazing sharing because that's what we want from the community. So
Yes.
addressed. It has been addressed. Mrs. Franklin?
All right. Okay, thank you. Let's move
My
on.
real
Yes.
question is, where have all the computations that we normally would stand before the board and share with students, where have all that evaporated to? I don't expect you to answer, Sister Franklin. I'm just asking us for reflective thinking.
Yes, thank you very much. All right. And the thing is, as our students do this kind of math, they get the enjoyment, the enjoyment come out and they're able. This is how they make the connection that we are talking about. Okay. So we have another one here. Mr. Hope brought 2/5 of his weekly wage for his wife and spent half of what he had remaining. If he now has $300, how much money did he get for his weekly wage? All right. So I'm not going to stay too long on this one. So we know that we are trying to find how much money was his weekly wage, the unknown. Okay, so let's look at it. So we know we are working with fifths. We do not know the whole, but we know that he gave his wife 2/5, and we also know that what he left, what was remaining from that 3/5, he had $300 now, because he did what? He spent half of what he had remaining. So how do we determine what was the whole? So,
Hi, good night.
yes,
It's
good
okay
night,
to
go
speak.
ahead. Yes.
In this case, we have the answer and we know that he gave his wife 2/5, and of the remaining, he spent half.
Right.
So in this case, knowing that half is 1 out of 2, we know we need to reverse it and multiply it by 2. That would give us 300. That means that not 300, sorry, 600. 600 represents 3/5 of the money there. So if we divide 600 by 3, we'll get we would get 200 each. So 1/5 represents 200. And in that, we can fill in that into each of the little boxes.
All right. Thank you very much for sharing. So let's just go through that quickly. What she's saying, he spent 2/5. Look, we have the 2/5 covered there in blue. And then, no, sorry, he gave his wife 2/5 and then he spent half of the money. So if he now has $300, it meant that the amount he had remaining had to be $600. So we have 300 there. The question mark there will be another $300. So if those 3 remaining boxes there, those white boxes are $600, it means that each of those boxes would be 200. And once one box is 200, all the boxes will be $200. So it means that Mr. Hope had how much money for his weekly wage?
$1,000.
$1,000. I hope we got that, colleagues. All right, let's move along. So we have another question here. Dave's dog weighs 4 times as much as his cat. Their combined weight is 60 pounds. How much do they each weigh? So Dave's dog weighs 4 times as much as his cat. So we want to know the cat's and the dog's weight. And we know that together they weigh 60 pounds. All right? So if the dog is 4 times the cat, if we have the cat's weight there, then the dog has to be 4 times that. Now we end up now with 1, 2, 3, 4, 5 boxes. So we have to take those 5 boxes now and share that 60 pounds that is there. It means that the cat, because all of them now have to be equal, okay? And I'm hoping that you are picking up about, you know, trying to make things equal as we go along here, okay? As it gets a little bit more difficult, the students are going to see certain things happening. So each of those would be 12. So make sure you understand the dog is 4 times the cat. So we put down the first box there for the cat, and then the dog we need to show 4 times that, okay? 4 times the cats. So we ended up with 5 boxes. So 60, and we have to divide that in those 5 boxes now. Each box would have 12. So how much do they each weigh? The cat would weigh 12, and the dog would weigh 12 by 4, which is 48. And if we add 48 and 12, we'll get back to 60. Are we seeing that? Let's move along again. So we have another one for us to look at. and you know, in the lower secondary also and so on, we have these items for our students also. And they tend to get into algebra and so on. So Fiona won 5 times as many games of Snap as Luke. Luke won half as many games as Shelley. Altogether, they won 72 games. How many games did Fiona win? Okay, let's look at it. Luke, we need to get Luke's number. We need to get Fiona's. And we also need to get Shelley's. Now, from the information we have here, we know that Fiona won 5 times as many as Luke. Okay? Sorry, the answer is already in there in this one for you. So we have Luke's score. Luke's his is done. His first box is done. Okay? Shelley, we know if Luke won half as many as Shelley. Shelley got, if we put down Luke first as 1, Luke won half as many as Shelley. It meant that Shelley got 2. And if Fiona won 5 times as many as Luke, then Fiona must be done 5 times. I want you to look at the information and see how it is being represented. So we ended up with how many boxes? 1, 2, 3, or how many bars? 1, 2, 3, 4, 5, 6, 7, 8 bars we ended up with. And if we have 72 games, then we have to consider what will go in each bar. So our answer is 9 in each bar. 9 in each bar. But it asks, how many games did Fiona win? Fiona won 5 times 9. Okay? Let's see if we are seeing that. Let's try to digest it.
So, Ms. Franklin, can you go over where we started? Where did we start in working this through? Which one did we start with?
So we start with Luke. Okay, we could start with Luke. Look at it. Fiona won 5 times as many games as Luke. Luke won half as many games as Shelley. And altogether, they won 72. So if Fiona won 5 times as many as Luke, we put down Luke and we go 5 times as many. So we have Luke, which is 1 box, and 5 times as many. And then the information said Luke won half as many as Shelley. So if Luke has won half, he won half as much as Shelley, it means that Shelley only had 2. Are we okay with that now?
Okay, so I'm thinking, so we might start with Luke, as somebody was asking there, how do we guide the children as to where to start? Is there a clue? Because then we say start from the known to the unknown. How do we guide the children as to where to start? Or could it that a next child starts somewhere else and still will end up with the answer? Could it be?
Where would you have started, or could you have started? Can you think of a different starting point? If we look at the information.
Mrs. Franklin, we have just two chats that I want to bring to your attention in
Yes.
line with what is being shared. Mrs. Marshall Cato asked, can we start with Fiona? So perhaps she wants to share this. And Mr. Blackett says that the student may not start with Luke's 1. So let's
go ahead. Either Miss Marshall or Mr. Blackett could start. Go ahead, Mr. Blackett.
Yes, good evening. Thinking as a student, the first name I see is Fiona. So I would want to start with Fiona. Luke further down. So it's unlikely that somebody would reach the whole question and find out what the other is doing. But it can still start with Fiona because once it says 9 to 1, I mean, at 9 to 1, I think it so happens to work out all right. So for this particular question, is not too bad.
Mrs. Franklin.
So you're saying that through trial and error, it could work?
No, in this particular case, if you start with Fiona and Luke, because Fiona was the first name and Luke was the second name, it would work out nicely in this particular case. But the other questions, depends how this phrase may not work out as nice.
Mrs. Franklin.
Yes.
Could we have it that we could start out with Frank just like that? So you said with Franklin. So I would say Fiona won 5. No, Fiona. Fiona won 5 times as many as Luke. So I would have 5 times Luke. So I just have Luke 5 times. 5 times Luke plus 2 times.
You're thinking
2 times
abstract.
Shelley plus Luke.
You notice you still have to fight. You still have to get Luke.
Yes, because you said Luke won half. So
you see,
Luke half of Shelley, which is Shelley's 2 times 2. So it would be 1. Luke would be 1.
Right. So I know you are trying to probably think of it in an abstract way, but remember we are trying to remove the abstract part of it there, okay? And we are trying to guide the students here, and we don't want to we don't want to make the students feel that you would see a slide coming up what we were trying to do here when we do this. Maybe you could save it. Lois, anything else before I go forward?
No, Miss Campbell's hand is up.
Okay.
Good night, everyone. I was looking at it as if the 9 wasn't given and we're using bars, right? So we know Luke has at least 1 bar. Shelley has twice as much as him. And Fiona has 5 times. So when I count up all the bars, I get 8. And we know it's 72 games. So dividing the 72 by 8 bars, we would get the 9. Because unfortunately the 9 was given. But if it wasn't, that's the approach I would see myself and even some of my students taking without any information given more than the question and the number of games. And once you find out how much 1 is worth, we can then multiply it for each of the other 2 persons.
The thing is not that the 9 was given so much. It's the question was really about the starting point, okay? And Mr. Blackett said student might want to start with Fiona, but the thing is if you start with Fiona, you're starting with Fiona, but you are still thinking of Luke in order to start with Fiona, okay? And Luke is still in the picture, all right? So even though we say start with Fiona, I'm still seeing that Luke is critical in setting up what we want to do. Now look at this, and I don't want us to get too abstract, okay? We are saying that what we are thinking is that as you use the bar model, things like this become what you're trying to talk about there in terms of the abstract. It makes more sense to the students now. So let's just look at what is here. If we have n, if we have a box, whatever n represents, this is an item in isolation, not related to the one, but still drawing from what it is saying. Once we have, let's say, one box, once we identify the first one that we are using to set up the problem with, or the bars with, once we have two times more, we know that we're ending up with 3 boxes. If we have 3 times as many or 3 times as much, we know that we should end up with 4. And if we have 5 times as great or 5 times more and so on, then we should end up with 6 boxes, because we have to take into consideration the person who, the one in question first. So Luke was the one in question here. Everybody was relating to Luke in this situation. So we set it up as the Luke is n here. This is what this is really saying. So when we do the bar model, afterwards, we could introduce concepts like these, or set up scenarios or situations, equations like these. Our students can know or be more appreciative of working these because they understood it through the bar model. Okay? They would have had the understanding through the bar model. All right? Louis, you were saying something else again? Or we could move on.
No, we can move on.
All right. All right. Now we are going to look at some percentages. And when we are doing the bar model, when we are doing the bar model, it is advised that you set up these benchmark percentages so that your students are familiar with them. Your students should become familiar with what 1% look like, what 10% looks like. 20% is 1/5, and 25% is the same as a quarter. So these things are very important for our students. So once they know those benchmarks, they are able to perform better when they have questions like these. I know you might say, this looks so simple, 30% of 60. But if we are trying to get our students to have meaning, conceptual understanding, the bar model is providing it here. So we have the whole percent here, the 100%, 60 represents the 100%. And in the 100%, we can break it down to 10 in 10%. Each of those could be represented with 10% going down there. Okay? Now, if our whole is 60, you have to determine how much would be in each of those boxes. Okay? But the thing is, we only want 30%. But when the students know what we talked about a while ago there, what 10% looks like, then a student can get 10%, another 10, and another 10. It is important that the student sees this kind of operation so they will know that 30% represents 18 out of the 60. Okay? This is the representation here. Remember, we are working the bar model. You might be saying, why not just let the students go right into it? and put 30 over 100 times 60 and so on. Remember, we are doing the bar model. Sorry. So let's look at this one now. Out of a school of 240 students, 70% like football, and the remaining students like cricket. How many students like cricket? Again, we know that 240 is the whole 100%. 240 is the 100%. So we know also 70% like football. Excuse me. So 30% likes cricket. I think my answers are showing. No problem. Excuse me, my voice seemed to be going now. So if we have our entire 240, we shared it up with our 10, in our 10%. Look at what we have there. Each of those would have 24. So our students can now tell how many students like cricket. All they have to do now, look at our 30% and see how many students will like cricket. So each one, that 30%, we add 24 3 times because 10% plus 10% plus 10% would give us 30%. So if we add the 24 3 times, we will get the number of students who like cricket. Okay? And from it, we could also tell how many students like football. Even though it said 70%, we could tell how many like football. All right, let's move on. This one is asking us to identify the whole in a school music band. 40% play pan, 28 of them play pan. This one is an interesting one. Look at this one. But the question is asking us, how many students are in the school band, in the school music band? 40% play pan. Look at it. 40 out of the 100% play band.
So you do the same as what you did in the first one, cut it up in 10 sections.
All right. So let's look at it. 10 sections. Let's look at it. Very good. But let's look at it. 40%.
And then you cut up the 40 in 4 sections. And then you're going to divide that into 28.
All right. So 40% is there. But that 40% represent what?
28.
Do we know it said how many children like pan?
28.
28. Now let's look at it now. It is important for us to understand those benchmarks we spoke about. That 40%, we can take it and cut it up into 20%. Not true? So we are taking the 40% now and splitting it. But that 40% is the same as 28. Are we correct? So if we cut the 40 and we get 20, we have to do the same with the 28. So with our 28, look at it. Now, what is important about 20%? What did we say 20% is?
14.
What fraction is our 20%?
1/5.
Okay, 1/5.
1/5. So, because we have taken the 20, the 40, we have split that 40, and we have gotten 20. In order for us to get the percentage going across there, now we're not going to cut in 10. We're going to go in 5. We're going to get 5 parts there now. So, when we splitted that 28, the 40 and the 28, we made them equal. If we made the 40, 20, 20, what should we make the 28?
14, 14,
14,
14,
14.
14.
So all of these will be equal to 14 also, going across there. Okay? Are we okay? So the question asks, how many students are in the school band? Now we have the entire 100% going across there. So we get 14 5 times there going across there, and we get the percentage. If we cut these 10% down, we'll get 7 in each of the 20% down, so that we can make 10. We will get 7 in each of those. So it will still hold. But for this, we have to be able to work with what is given. 40% is what was given. So we have to split that 40 and get 20 so that we work with easier numbers. We get our students to see how it is to work with easier numbers. So we have to make sure we get those benchmark numbers in, okay? Percentages in. And we can also do this as we do percentage increase and decrease.
Mrs. Franklin?
Yes.
We are wrapping up.
Yes, we are.
Thank you.
So it can work for percentage increase and also decrease. If it asks us, if it says a laptop is increasing, I'm just gonna do this last item. A laptop is increasing, it's at $450. That's the whole price. But then we are going to add on 20% more. We add on 10%. Look, we get 20% because each of those are 10%. We get to our total. So our 450 plus 2 more 10%, which is 20. And we are adding 450 plus 90. Colleagues, as you work with these, you are going to see it takes practice. And it takes practice on your part as the teacher to be able to understand this. It takes practice on the part of the students. So you work with simple numbers and so on for them to understand. But you're going to find that the bar model is really a very good strategy that helps our students, and they're able to visualize a lot of the work that they are supposed to do. The only other one I think we had left to do was the ratio, but you can always go and research that. So colleagues, thank you very much for your time and for really participating in this session today. Thank you very much. Over to you, Dr. George.
Thank you so much. We are seeing the appreciation through the emoticons and the emojis, and the participation this afternoon was clear. People unmuted. The chat was always very, very busy. So that alone is an indication that we have appreciated what you have shared. So thank you so very much, Mrs. Franklin, for that insightful and dynamic presentation. You have clearly demonstrated how bar models can transform how students see and make sense of mathematics. And in doing so, you have truly brought to life our theme for our webinar series, Empowering Educators to Transform Mathematics Learning. And we should have seen that the bar model can be used across all educational levels, a lot of people looked at the content and said, oh, that's for young children, that's for primary school children. But the problems that we were seeing in your examples shows us that, they show us that we can use the bar model across the different educational levels. To underscore one of the last things that you said, it takes practice, and I'm adding intentionality to incorporate any type of tool for effective math teaching and learning. In the chat, several people were saying you have to choose the right problems, you have to think about the trajectory of learning, etc. And therefore, it's not a one-shot thing. So one of the things I want to encourage us to do is to actually implement some of the things that we have been discussing, not just in this webinar, but in the last webinar where we looked at the bar model. Actually try it out in your class. And it is absolutely normal if the first time that you try to incorporate these different types of tools, especially if children have been taught using a rote type of way or in an abstract way, it doesn't go well the first time. We want to stick with it and get our kids accustomed to using different representations, different tools for engaging with math. But it depends on you. You, the teacher, you have a pivotal role where that is concerned. Because the long and short is, and I won't be very wordy or long, most of our math classes still emphasize rote learning, abstract reasoning, and procedural fluency. That's the long and short of it. That's the long and short of it. And we really hope that this series, it aims to promote a shift towards classrooms where our students are guided to build understanding until they reach true mastery. So we are sharing in the chat our evaluation form just to give us some feedback as to how you found the session, how beneficial it is for you. As I shared in the chat, we are working out the most effective way to share both the resources and the actual presentation with you, because we know we want to reach a wider cross-section of people. And I know some of the principals in this room, numeracy coaches, education officers, and teachers, you would want to share this content with your colleagues, with your fellow teachers, etc. And we want you to be able to do so. So we are still working out some processes, so please be patient with us as we do so. Since we have been so interactive, we may not have too many questions, but we have space for just one question or maybe two short ones for Mrs. Franklin as we bring this activity to a close. So any questions, anything that you have been wondering about, the link is being shared for the evaluation. Please just click on it. It's just a few questions, 2 minutes is going to take. Please just complete it so that we have the data to ensure that we continue meeting your needs. Let us know if we are, meeting the needs as we envisioned, because we want to ensure that it's not just about us doing, but you are receiving what it is that we have planned. So our next webinar, I'm still waiting for the questions in the chat and so on. So in the meantime, I'm just continuing. Our next webinar will take place on Tuesday, November 18th, and it focuses on breaking the fear barrier, transforming math anxiety into confidence. We have an amazing speaker, Mr. Dido, from Florida, will be really unpacking this for us, and it really promises to be an amazing session. There will be no sessions in December as we pause for the holidays, but we come back in January 20th, with our session on the use of AI in mathematics teaching and learning. Let me just check the chat for any questions. No questions. Andrea Archer Brown, your mic is unmuted. Did you want to say anything, ask anything?
No, thank you. I did not know my mic was still on. I'm so sorry.
No problem. No problem.
I'm filling out the evaluation form.
Okay, thank you so much. So at this time, on behalf of the Commonwealth of Learning, the Virtual University for Small States of the Commonwealth, and the UE Mona School of Education, and of course our country coordinators. Thank you so much for being part of this growing community of practice. We want to find different ways to engage persons, not just in landed campuses like Jamaica and Trinidad and Barbados and now Antigua, but all across the region. You should have access to high quality math professional development ongoingly, not once in a blue moon when people, you know, wake up and think, okay, let's do this. So this is our goal, and I hope we are achieving the goal. We look forward to seeing you next month as we continue to empower educators and to transform math education across the Caribbean region. Have a wonderful evening, everyone. Get home safely if you are not home, and thank you so much for logging on and staying. You actually stayed. We had about 100 of us today, and we are hoping to double and triple that number next month. Have a good evening, everybody. Have a good evening.
We're still signing up, please.
Sorry?
I'm still signing in. I'm still doing the evaluation.
Yes, we're leaving it open. Stay here and complete the evaluation. We are not rushing you off. We are going to put, you know, the lovely music on so that you can jig a little while you are waiting. And please complete the form. Do not leave until you have done so, but we will send it to you just in case you did not get the chance. All right. Thank you, everybody. Thank you so much. Mrs. Callum, are we getting the music to take us out?
One moment.
Is there a form to fill out before we leave this Zoom meeting?
Yes, there is, Ms. Campbell, and I'm just putting it again in the chat in case you missed it. Thank you for asking.
Thank you.
Goodbye, everyone. Have a good day.
Thank you so much, and you as well.